we will examine what happens when two waves encounter each other. Two pulses of the same amplitude are produced at opposite ends of the spring and travel in opposite directions. After meeting in the center, the waves pass through one another unchanged, as each wave looks and travels just as it did before the encounter. However, in order to see what is happening during the short time when the two waves overlap, slow motion will be used. The two approaching waves have upward displacements and are of the same amplitude. When the waves partially overlap, a new complex-looking waveform is suddenly created. As the waves move so as to completely overlap, the newly created wave is observed to have a displacement which is greater than that of either pulse individually as the two pulses reinforce one another. This result is due to constructive interference, and in accordance with the principle of superposition, the total displacement of the spring at any instant is equal to the sum of the displacements of the two pulses independently. After the interference takes place, the two pulses assume their original shapes and continue their propagation along the spring. Next, two waves of equal amplitude but opposite displacement are produced. The waves are once again observed to pass through one another unchanged. However, as the waves overlap, there is clearly a moment when the entire spring appears undisplaced as the two waves completely cancel each other. This is a result of total destructive interference and is caused by the positive upward pulse adding to the negative downward pulse to produce a zero displacement. Although the wave is momentarily destroyed, the energy of the disturbance is not. The energy is still very much present and can be shown to be stored in the spring. Afterward, it is seen that the wave cancellation is only momentary, as the two pulses reappear on the spring, showing no sign that destructive interference ever took place. If an upward pulse of relatively small amplitude encounters a downward pulse of larger amplitude, the result can be predicted based on the superposition principle. The two pulses interfere destructively, although total destructive interference does not take place. The displacement of the small upward pulse subtracts from that of the larger downward pulse, giving a net result of a small downward displacement. As expected, the pulses pass through one another and return to their original size after the interaction.